For decades, flood protection was based on one idea: remove water as fast as possible. But in extreme rainfall, speed creates overload. The new approach is the opposite. Store water, slow it down. Let it infiltrate. Reuse it. This is the sponge city principle, and it can begin at the scale of a single home. In conventional design, each surface works independently. The roof drains to the sewer. The driveway sends water to the street. The garden plays no hydraulic role. In a sponge-integrated plot, everything becomes part of one coordinated system. The entire property is treated as a small watershed. Every drop is managed within its boundary. Flood resilience is not achieved with a single solution. It is achieved through layers. Each layer performs a different function. Green roofs store and delay rainfall. Permeable pavements infiltrate surface water. Rain gardens absorb overflow. Swales transport water safely. Underground tanks provide final buffering. Together, they eliminate uncontrolled runoff. Rain gardens are engineered depressions with highly permeable soil and selected vegetation. They temporarily store runoff from roofs and pavements. During peak rainfall, they act as surface retention basins. After the storm, water infiltrates into the ground or is taken up by plants. This reduces both flood risk and irrigation demand. A landscape element becomes a hydraulic structure. Swales replace traditional drainage channels. They slow down the flow using vegetation and shallow geometry. This prevents erosion, increases infiltration, and improves water quality. Instead of transporting water away as quickly as possible, they guide it through the plot. Time becomes the key flood protection parameter. Healthy soil is one of the most effective water storage systems. Organic matter increases its capacity to retain moisture. This stored water reduces runoff, supports vegetation, improves microclimate through evapotranspiration. Soil management becomes part of flood engineering, not just a landscaping decision. Smart systems connect all sponge elements. Before a storm, storage tanks are partially emptied to create capacity. During rainfall, flow is distributed between infiltration areas. After the storm, stored water is reused for irrigation. This creates an adaptive plot that responds to weather conditions in real time. The property becomes a living water management system. When many homes adopt this approach, the effect extends far beyond the individual property. Street flooding decreases. Drainage systems operate within capacity. Urban heat is reduced. Groundwater is recharged. Flood resilience becomes a distributed network, not a single centralized infrastructure. The future of flood protection is not only in cities, it is in every plot.